Welcome to the DIY Honda Garage channel. The error code P177A in the 2011 to 2017 Honda Odyssey refers to a condition where the line pressure solenoid valve A is stuck in the off position, or the line pressure switch is stuck off as well. The line pressure solenoid valve is critical in regulating the hydraulic pressure within the automatic transmission, which directly affects shifting performance and transmission efficiency. Meanwhile, the line pressure switch monitors the line pressure and communicates with the powertrain control module, PCM. Ideally, when the solenoid is activated, the pressure switch should read as on, and when the solenoid is off, the pressure switch should reflect off as well. Therefore, any faults in these components could lead to a range of transmission-related issues. The next steps involve a systematic approach to troubleshooting the outlined DTC, ensuring accurate diagnostics, and establishing the root cause before proceeding with repairs. The P177A error code indicates an electrical issue specifically related to the line pressure solenoid valve A and the line pressure switch within the automatic transmission system. The line pressure solenoid valve A is essential for determining how much hydraulic pressure is sent throughout the transmission, and it is situated inside the transmission assembly, which makes it relatively difficult to access. The line pressure switch, on the other hand, is responsible for providing vital feedback to the powertrain control module, PCM, about the status of the hydraulic system. Together, these components enable smooth gear transitions and optimal vehicle performance. If either component fails, it can lead to erratic shifting or even failure of the transmission to engage appropriately. Thus, understanding their locations and functions is crucial for effective troubleshooting. Several potential causes may lead to the P177A code being triggered. A faulty line pressure solenoid valve A is one of the primary suspects. If it is unable to open or close as intended due to internal issues, it will result in incorrect hydraulic pressures. Another potential issue could stem from a defective line pressure switch. If this switch is not providing accurate feedback to the PCM, it could lead to erroneous operation. Additionally, wiring issues such as short circuits, poor connections, or damaged wiring harnesses could interfere with signals between the solenoid and the PCM. Each of these components plays a pivotal role in the overall performance of the vehicle's transmission system and should be inspected thoroughly during troubleshooting. The symptoms associated with the P177A error can manifest in various ways, primarily affecting the drivability of the vehicle. One of the most common symptoms is erratic shifting, where the transmission may hesitate during gear changes or shift suddenly without warning. Additionally, drivers may experience no engagement of gears, which means the vehicle may not move when shifted into drive or reverse. This situation can stem from fluid pressure issues when the solenoid fails to operate correctly. Furthermore, regardless of driving conditions, the transmission might also exhibit signs of overheating, primarily due to excessive hydraulic pressure being developed or insufficient lubrication caused by faulty components. Each of these symptoms could indicate underlying problems that necessitate thorough inspection and resolution. The first step in troubleshooting the P177A code involves warming up the engine to its normal operating temperature. This requires that the engine runs until the radiator fan kicks in, indicating that the cooling system is working and that the engine has reached a suitable temperature. Proper warm-up is crucial because many thermal-related issues can only be replicated when the engine is at operating temperature. It ensures that the transmission fluid has reached optimal viscosity, allowing for accurate testing of the solenoid and pressure switch operations. Therefore, this initial step sets the foundation for all subsequent diagnostic actions, ensuring that the components are tested under standard operating conditions. Next, it is essential to check the transmission fluid level to ensure it is filled to the proper amount. Low fluid levels can significantly affect the performance of the transmission, leading to shifting problems or even complete failure to engage gears. If the fluid is low, it is important to find and address any leaks in the system before continuing with more in-depth testing. Fluid leakage can stem from several locations, including seals, gaskets, or transmission cooler hoses. Regular inspection for leaks can help prevent more extensive damage to the transmission system and avoid costly repairs. Therefore, confirming that the fluid level is adequate and no leaks are present is a critical step in diagnosing the P177A code. The third step entails draining the automatic transmission fluid, ATF, through the strainer. This action is necessary to check for metal debris or excessive clutch material, both of which could indicate internal wear or damage in the transmission. The presence of metal particles suggests wear from internal components, while excessive clutch material may point to issues with the clutches themselves. These observations can offer critical insights into the overall health of the transmission. If metal debris or excessive clutch material is found during this inspection, the recommendation would be to replace the transmission entirely, as it indicates significant damage may have occurred. Conversely, if the strainer is clear, the next step would be to replace the ATF and proceed to further tests. Following the fluid inspection, the next step is to block the rear wheels and raise the front of the vehicle. This step is critical, as it allows the front wheels to rotate freely without hindrance, which is essential for accurate testing of the transmission system. Ensuring the vehicle is securely supported is paramount for safety, particularly if this is done using a hydraulic lift or jack stands. Properly securing the vehicle prior to testing can help prevent accidents or injuries. This step prepares the vehicle for further diagnostics that involve operations of the line pressure solenoid and pressure switch in a controlled environment, where free wheel movement is necessary for testing. Now that the vehicle is safely positioned, turn the ignition switch to the on second position without starting the engine. This action is essential as it powers up the vehicle's electrical systems, including the HDS, Honda Diagnostics System, which will be used for further diagnostics. By bringing the vehicle to this state, you prepare its electronic control systems for communication and testing. At this point, key components of the transmission management system can be activated and monitored, which is vital for identifying faults or operational issues. This step marks the transition from physical inspections to electronic diagnostics, enabling a comprehensive evaluation of system performance. Once the ignition is in the on position, the next task is to clear the DTC using the HDS. The Honda Diagnostics System allows mechanics to reset the vehicle's trouble code memory, effectively clearing existing codes from the system. This action is important because it helps in identifying whether the problem is persistent or intermittent. After clearing the code, a new drive cycle can be started without previous codes influencing the results. This step is integral to obtaining a clean slate for further diagnostics, ensuring that any new codes generated will be relevant to the current conditions of the vehicle. It prepares the system for a fresh evaluation to verify the functionality of the components in question. Following the clearing of the DTC, the engine needs to be started while keeping the brake pedal firmly pressed. After starting, shift the transmission into drive D and then release the brake pedal. This sequence allows the vehicle to operate under a controlled setting, similar to normal driving conditions, while monitoring the transmission's response. It's crucial to perform this step with caution, to avoid abrupt movements. This process enables the technician to evaluate how the transmission engages under these conditions, thereby assessing the line pressure solenoid valve and the related pressure switch's functionality. Observing how the vehicle behaves during this step provides valuable feedback for subsequent diagnostics. The next step is to monitor the accelerator pedal position, APP, sensors output using the HDS as you manipulate the accelerator pedal. The APP sensor communicates the position of the accelerator pedal to the PCM, influencing engine and transmission responses. Press the accelerator pedal to a 2% opening and release it to a 0% opening every 2 seconds while observing the line pressure solenoid valve A's response. The desired outcome is for the line pressure switch to be on when the line pressure solenoid valve A is also on, and off when the solenoid is off. This relationship is crucial to determine if the components are functioning correctly. If both components indicate the expected signals, it suggests that the system is currently operating normally. While inconsistencies may indicate intermittent failures or underlying issues in the electrical connections that need further exploration. In the 9th step, you will select the line pressure solenoid A from the HDS miscellaneous test menu to check its operational status. This test involves observing the solenoid's activation through the HDS, which should emit a clicking sound when it functions correctly. The clicking sound indicates that the solenoid is receiving signals from the PCM and is responding appropriately by moving its internal components. If a clicking sound is heard, it suggests that power is reaching the solenoid and it is likely working correctly. However, if no sound is detected, it signifies a potential problem requiring further inspection, possibly indicating a failure in the solenoid itself or an issue with the electrical signal from the PCM. Now, turn the ignition switch to the lock position. This step is important for safety and to ensure that no electrical current is flowing through the vehicle systems while conducting the next inspection. The next task is to check for a blown number B3 15A fuse in the underhood fuse relay box. A blown fuse can interrupt the electrical flow to components involved in the transmission system, causing error codes like P177A to appear. It is crucial to verify the condition of the fuse to ensure that it has not blown and that electrical continuity is maintained. If the fuse is intact, the troubleshooting process will continue. Otherwise, replacement of the fuse should be performed and the condition reevaluated. After turning the ignition off, if you have confirmed that the number B3 15A fuse is blown, this indicates a potential short in the wiring, which needs to be addressed. The fuse connects various components within the transmission circuit, and a short to ground between the PCM connector terminal B2 and the underhood fuse relay box could be the cause of the blown fuse. To solve this issue, visual inspection of the wiring harness and connections should be conducted to ensure that there are no exposed wires, damaged insulation, or any signs of shorts. Once the short has been repaired, a new fuse should be installed, and the system should be retested to determine whether the P177A code remains or if functionality has been restored. The 12th step involves jumping the SCS, Service Check Status line, with the HDS, which allows communication with the vehicle's onboard computer system to facilitate diagnostics. This process prepares the vehicle for calibration and programming actions required to ensure the optimal performance of the transmission after any repairs. By jumping the SCS line, you enable additional diagnostic capabilities that may assist in identifying further issues if they exist within the system. This step is essential to ensure that any potential faults can be clearly identified and addressed promptly, ultimately leading to a more effective resolution of the P177A issue. In this step, You disconnect the PCM, Powertrain Control Module Connector B, which has 49 pins. Unplugging this connector is crucial for measuring key voltages at specific terminals accurately. It isolates the PCM from the circuit, ensuring that measurements related to the line pressure solenoid and pressure switch can be done without interference from other sensors or electronic control signals. Once the connector is disconnected, the next step will be to perform voltage measurements to determine if the solenoid and switch are receiving adequate power from the system. This action helps to confirm whether the electrical pathway is intact. Continuing with the troubleshooting process, turn the ignition switch back to the on-to position after disconnecting the PCM connector B. This action provides power to the electrical components, which allows for voltage measurements to be taken accurately. Measure the voltage at PCM connector terminal B2 and body ground. A proper reading will confirm whether the solenoid is receiving sufficient voltage necessary for its operation. If the voltage reading is below specifications, it could contribute to the failure of the line pressure solenoid valve A. By examining these voltages, technicians can narrow down the issue to either the solenoid, its connections, or the PCM itself. After completing all troubleshooting steps and necessary repairs, the final verification involves confirming that the P177A code has been resolved. This is typically done through a test drive of the vehicle to ensure that the transmission operates smoothly without any error codes reappearing. During the test drive, observe the shifting patterns, responsiveness, and overall performance of the transmission system. It's important that the vehicle performs as expected under normal driving conditions. If the vehicle operates correctly without issues, this confirms that the repairs were successful. Otherwise, additional diagnostics may be necessary to check for lingering issues that could be affecting the transmission. To prevent troubleshooting the P177A code in the future, regular maintenance practices should be implemented. One of the most vital steps is frequently checking the transmission fluid level and condition. Maintaining adequate fluid levels and ensuring the fluid is clean help improve the longevity and performance of the transmission system. Furthermore, monitoring the overall performance of the transmission can help identify issues before they escalate to the level of triggering error codes. Keeping an eye on shifting patterns and responsiveness allows for quicker response to potential issues. Regular maintenance not only helps in preventing costly repairs in the long run, but ensures optimal operation of the vehicle. In conclusion, the DTC P177A signals significant issues within the transmission's hydraulic control system and emphasizes the importance of systematic troubleshooting. Understanding the roles of components like the line pressure solenoid valve A and line pressure switch is fundamental in diagnosing transmission problems accurately. Each step in the troubleshooting process, from engine warm-up to checking electrical signals, provides vital data that guides technicians in identifying the root cause of the issue. Regular maintenance, including monitoring fluid levels and inspecting wiring, can preempt many transmission problems, ultimately safeguarding vehicle performance. Armed with these insights and methods, technicians can address DTC P177A effectively, ensuring vehicle reliability and safety. Please like and subscribe to the channel. See you next time.